Good morning, everyone. Through the work we've developed, we think there might be an opportunity around $300 to $400 million for the forest industry in the mid-rotation window. I'm briefly going to go through some of the work that we've started, and we started with this review back in 2013. We looked at some of the opportunities around herbicides at mid-rotation, and we thought that was quite challenging. We also looked forward to the potential use of microbes and stimulants at mid-rotation. And then we looked at the conventional practices, something that's already embedded in the industry and how we might improve those. And some of those are the fertiliser applications, with the typical urea applications and the DAP. And so we heard from forest growers, it's a bit like at the Rugby World Cup, trying to predict the upsets. The confidence in some of the urea applications is not high. The team did a little bit of a review. They looked at some of the field trials across New Zealand, and they showed some positive gains in growth rates early on. You can see by the stars and the upper bars. But also, below that line, some of the sites were not responding positively. We think now that's probably related to a phosphorus availability and some other nutrient limitations. And so that developed the concept of a balanced nutritional approach, or co-limitation. And so nutrition, thank you. Nutrition is limited at different scales, and as we work towards precision forestry, it's going to be more important for us to understand which nutrients are limiting at which sites. Not all sites are the same, and so that's what we're trying to do. One of the major considerations is for these fertiliser applications is understanding the processes, and here we're trying to look at the nutrient pools, the effects on the environment, and how we're influencing factors that might be important to us in the future, like climate change, fixing carbon and the such. So what we did, what we did is we established 9 field trials across New Zealand. These field trials were pretty much random. We asked forest growers what sites were available at the time that we wanted to put some trials in. And so they weren't specifically deficient on any nutrients that we understood at the time. What we did is we went into those sites and we collected some soil samples and looked at some of the nutrients that were available, and then tried to determine what was a suitable product to be applying at that site. So we also compared with the site-specific fertiliser application a urea, which is a conventional practice. So here I picked out 2 examples. I've only got 10 slides, a bit like a Bathurst hot lab. I'm trying to race you through some of the concepts, but I'm really happy to talk to you later about what we can do for you guys. So at Berwick, we found there was a low potassium, and so in our site-specific fertiliser product we added nitrogen, but we also added potassium sulphate and a couple of other treatments. We did have some challenges. We didn't always apply nitrogen with the products that were limiting at the site, and the Kyengaro example is a perfect case study here. What we did is we applied magnesium sulphate alone, where we probably would have got a beneficial gain if we had added it with nitrogen. But I think this is a much more greater learning opportunity for us, because we need to understand what's going on in this case. So we know what drives grower uptake, and that is value. That $400 million potential I identified earlier is based around an Atlas forecaster prediction from the growth responses of 5 trials that had been in the ground for 3 years with these fertiliser treatments and 4 trials that had been in the ground with 2 years. And so what we're showing is that there's a change in volume at the end of rotation for those stands. There's an increase in the allocation to the larger and higher value logs, and there's an increase in the total standing value. If you scale up that $4,642 per hectare to the window at the mid-rotation, you get to some significant numbers across the industry for an individual, just depending on what stands are available. So some of the other opportunities we're trying to develop is foliar fertiliser applications. It's common in other sectors that they're using it elsewhere in agriculture, and so we think it's a technology that we can adopt in forestry. It adapts well to UAVs for small growers, where the size of their plantations or woodlights is more suitable to UAV applications as spray products. You can put lots of different products through spray formulations, and that's very good. It also, it's better at targeting the crop, and so the environmental benefits and the nutrient use efficiency is much better. We started looking at foliar fertiliser options through some screening trials, through some small seedlings in the nursery using highly controlled environments, and we showed these benefits of the lower rates. We also showed and confirmed the interactions or the needs of some different genotypes, different nutrients, or utilising nutrients differently. And also we showed that the applications at different times of the seasons also mattered, or were an opportunity that we could develop further. So the graphs here just demonstrate how we've looked at the different products. We screened a lot of different products, and we've compared them on a cost basis and also on a potential productivity gain basis. And this graph here shows some differences between the seedlings in terms of what they responded, how they responded. So in general terms, the impacts to forest managers is that we believe now that you pay more attention to nutrition management and crop nutrition. Several forest companies have started or renewed their own nutrition management programs, specifically including a balanced nutrition trials where we've got a specific radiata fertiliser blend identified, and we're developing that. We also think that we can provide growers with new mid-rotation options, much more sensitive to site and tree demands, while also addressing environmental concerns. So with a projected average of $4,642 per hectare, how big is the opportunity? How many growers, will get on board with this? So also, the opportunities earlier in the stand around thinning time, and Mike, if you'd like to detail some of that.